Hello, so now what I want to do is show you how to put together one of these 3D printed robots that I've designed. We actually uh, we actually have our students purchase, for example, a battery pack and a motherboard as part of their lab fee. And it's nice if they have the option of printing a robot when they leave the class that they can mount the stuff on. That way, the only thing they have to purchase is a couple of servos, and they can continue on their own outside of the class. So that's the reason why this whole system has been designed. But to get started, first thing you want to do is you want to go ahead and place a servo, and I'll pause this from time to time. You don't have to watch me screw all these screws in. I try to use the shortest practical screw, and what I end up doing in this case is starting with a 1/4 inch 440. And when it comes to the servo, you have to put a washer on it. Now the way I have it designed, you should be able to just press the screw firmly while attaching it, and it should dig into the plastic and get a good bite. Okay. What you don't want to do is tighten all the screws all the way down, or I'm sorry, don't want to tighten this screw, for example, all the way down until you get at least the other three partially in place, and then tighten them all down. If it doesn't go in, what you can do is use something like I have one here someplace. There it is. If you have a tap, that's awesome. But what you can get, which is really cheap, is just a self-tapping screw. So you can use a self-tapping screw to tap into the hole a little bit if it gives you a hard time. Anyway, let me pause this and I'll put all these screws in and I'll be right back with you. Okay, so you can see that I've got all 8 of these screws in. Okay, they all have washers. These were all 1/4 inch 440s. So you can kind of see the layout. So the servos go this way. Ultimately, what's going to happen is the wheels are going to go on like this. All right. So before we do that though step, let's go ahead and put the tail ball on. Now, this actually has a lot of variability depending on your printer, and it has to be pretty reasonably good. You don't want it so tight the ball can't roll, nor do you want it so loose that it falls out. I bought a bag of marbles like this from the dollar store, which gives me lots of choices, and of course they're cheap, so there's a lot of variability. So it's a matter of just grabbing one and popping one until you get a nice snap, okay, and finding one, and in this case it rolls really nice. So this guy goes here. This piece was not designed by me. I'll have a reference to it on the page, but it was rescaled slightly by a student of mine, and that way it fit into holes that we had designed onto this chassis. I could have done it a little bit differently, but why reinvent the wheel? It was a perfectly great design the way it was. So this just goes on. Again, I like to use the shortest practical screw that goes into the material. So that's a 1/4 inch 440. And now we've got a nice tail wheel. And these wheels go on here like this. Okay, like that. And like that. And these get attached with the existing screws that come with the servos. Oops. Sorry about that. And again, I might as well pause this while I set these 2 screws in. I'll be right back with you. Okay, so you see I've got the wheels attached with the existing servo screws. Okay, these 2 large O-rings simply snap into the groove, like so. Now we got this all set up. And currently we have a couple of different plows that have been designed. This one is nice. It holds lots of different sensors. I'll have the files for this one, as well as in a zip file I'll include the SketchUp designs. This was designed by one of my students because he wanted to have a robot that played soccer with a Bluetooth control. So he had 2 robots actually built, and you could duel each other on a small soccer field pushing a tennis ball around. And it goes actually either up like this, or it goes down like this if you want it to be low. But actually in this case, I'm going to go ahead because I'm going to put some sensors on this robot for some experiments. And I'm going to attach it below deck like this. And I'm probably going to use a slightly longer screw. It's a pretty deep hole, so I'm going to go ahead and use a 3/8 inch. Okay, and I will attach this plow or sensor holder or whatever, the front end piece, like so. And again, it usually goes in fine with just a little push, but you may have to, depending on your printer, you might have to tap that hole out or change the hole size, I suspect. If you want it to be just, it's pretty remarkable that it works this well, that it just goes in so tightly without actually any tapping or drilling. So let me do this one. Again, in this case I'm using a 3/8 inch 440 screw. And there we go. And now the top, this goes on like this, okay? And I will pause. I don't think it's worth it to watch me put in 4 screws. I'm going to go with a 1/4 inch 440 to attach this. And of course it goes into through this hole, oops, and into these 4 holes here. But I'll go ahead and pause it, and I'll do that. Okay, so this went in, and you can see I've got these 4 1/4 inch 440 screws that are attaching it. And now you have a couple of choices. We use the Patton's Robotics motherboard, okay, which is designed to fit this way, and so the hole spacings are set up for it. But if you're stuck with an old Arduino, for example, I will include an adapter plate, okay, into the file. So you can go ahead and attach this, for example, with 4 small screws, and then you can put the Arduino on like so. But like I said, I'm going to go ahead and put this motherboard on with the teensy on it. And what I like to use for these is it's still nice to have a little spacer here. And what I think works really, really nicely are the little rubber gaskets that get shipped with most servos. A couple reasons. One of the really nice reasons, of course, is that it actually kind of stays when you slide it over the screw, so you're not fumbling around. And I'm going to be using a 3/8 inch screw here. And that way I can push these gaskets on, spacers on, and they will just stay there like so. Okay, and this is going to go just like this. When I put these screws in, what I don't want to do is make it, since these are rubber and compressible, I don't want to squeeze it all the way down. I want it to go until the screw comes just flush on the outside. And that's also going to be kind of important for sliding the battery pack in. But let me go ahead and pause this, put these screws in, and I'll be right back. Okay, so I've got the motherboard attached. It's kind of convenient. I like the way it lays out, so it's sort of facing you as the user when you're working on it. And now what I'm going to do is take these 2 servos. I'm going to plug them in down here in pins 11 and 12. Notice that the lightest color wire is closest to the chip. That's where the signal is. The dark wire, the ground, is furthest from the chip. And I'm going to be running this board probably, I'll run it at 5 volts. So these motors will actually be running off the voltage regulator when it's running. And I'm going to have the processor set at 5 volts. And so there you go. I'm sorry, not the processor. The processor runs at 3.3, but this side of the board set at 5 volts. And this battery pack kind of just clips in here like that, so it doesn't fall out, which is nice. It kind of locks in place. And that goes right there. And we are ready to go. Oh, wait, no, we're not. Let me put a sensor on it. I'll be right back. All right, so actually, this little piece right here will hold a number of different things. I have already posted a universal sensor set or bracket set. And one of the things which is kind of cool is if you want, and I'll have it linked to this as well. For example, this is a clamshell that holds an ultrasonic sensor, which goes together like this, okay? And then this piece, for example, will just go right here, and there's a through hole that you can adjust it so you can bring it up and down or mount it any way you want. You can also put, for example, a sharp sensor on here, which is this one here, which again would mount right on this way, so you can set it at any angle. And if you want, you can put an extension arm in it, so you can have this thing extended out, okay? So you can do a variety of different arrangements with any one of these universal bracket sets, okay? And I got a bunch of other different attachments that will actually fit into this similar structure. So hopefully that was useful, and I'll see you again soon.